And welcome back, and a happy new year 2020. If you're watching this, of course, in January 2020. If you're watching this in June 2023, then, well, happy new year anyway. Okay, what we've got on the workbench today then is this little Brain Dead chip. Sorry, did I say that out loud? This little 13A. This is an ATTiny13A. Not much different to the 13, actually. They're pretty much interchangeable. And I looked at this because, yep, you guys said that last sketch we did, whatever it was, for the ATTiny85, we could fit that into an ATTiny13 because ATTiny13s are like 30 cents each or thereabouts. So cost-wise, it's really effective. What you didn't tell me was that it's so stupidly brain dead, oh, I said it again, that you just can't do anything with it. Or can you? Well, let's have a look. I've got this hooked up at the moment to the ATTiny85 programmer, but actually this works for any 8-pin ATTiny chip. Okay, so this is the same one that I was using for the ATTiny85. 13 stuck in there, and all I've got connected to it on these wires is an FTDI serial to USB converter there. So it's grounded, so you've got common ground and physical pin 5, just to see if I can get something out. Because, let's just take one step back for a minute. The reason why I was always a bit hesitant about using an ATTiny85, one, you've got limited memory. Two, you've got limited pins, so 6 at a push, normally 5 though. And three, there's no inbuilt UART. You have to create your own serial output, which on the ATTiny85 you can do fairly easily with software serial or simple serial, basic serial. There's lots of libraries and bits of code out there that purport to give you a serial output. And on the 13, it's the same code, sort of, not quite though. But let's just have a look at the serial output first, and then we'll talk about all the cores and stuff that I've got loaded on here and just see how well it works. I just wanted to mention my sponsor for this week. It's China's leading electronics components distributor, LCSC Electronics. From their warehouses in Shenzhen, China, and with more Asian brands and lower prices, they can pick and ship our orders in just 4 hours. And all their components are sourced from authorized distributors or directly from their Asian suppliers at very competitive prices. And if you have many components to buy, you can import your bill of materials BOM file directly into their website. Try it now. Right, let me bring in the cool term serial monitor. Right, there it is. So I'm going to reset the chip, if I can find it. So I'm going to reset the chip and then connect so we get it right from the start. Right, there we are. It's actually producing some serial output, and it's, oh, what happened to 4 and 5 and 7? Oh, that's a bit odd, isn't it? Well, these are the sort of problems I've been having for, it's probably 2 days between Christmas and New Year, trying to get a serial output on the ATTiny13 or 13A that was consistent, reliable, and worked well. And I know a lot of you are probably saying, that's probably not working because you haven't tuned the chip. Oh, yes, I have. Oh, no, you haven't. Oh, yes, I have, because I spent a good day working out what the OSCCAL value of the chip should be, so you can modify the internal calibration of this chip at 9.6 megahertz or 4.8. Those are the 2 internal oscillators that this chip has. Yes, 2 separate ones. It's quite bizarre, really, isn't it? Now, this will also run at 1.2 megahertz, but guess what? There's no OSCCAL value that it will store internally for that value, even though this chip would seem to be ideally suited for sort of battery powered operations where perhaps you do want to run at 1.2 megahertz because it takes just a few microamps then runtime. I think it's like 300 or something, 300 microamps running, and you go, that's perfect, that'll make my battery last a long time. But no, the 1.2 megahertz you cannot tune except manually. So what you do, you work out what the OSCCAL value is, so the frequency of delay that you're introducing as part of serial output, for example, changes the oscillator value, and suddenly, bink, your serial output becomes readable as this is, well, the serial test bit of this is, I don't know what this funny number is half the time now. I mean, why is it doing this? I have no idea. Anyway, you do all that, and then what you normally do is store it in EEPROM. EEPROM value, the first cell, so position 0, and then whenever you start up your sketch, you just go and read the EEPROM.read, I think it's EEPROM.read, brackets 0, so you get the value in there, stuff it into OSCAL, which all you just say is OSCAL equals, in this case, 5D. And I spent a good day trying out various methods of working out what the OSCAL is. And then I read that, well, really, you should work out first what it's set to in the factory. So in the factory, they calibrate these chips. And ATMEL say, well, ATMEL said, I guess it's Microchip's saying now, they will calibrate these to within about 10% of their actual value. So 9.6 meg plus or minus 10%. As it happens, they do better than that, and it's probably within about 1%. I mean, they're pretty good. Anyway, so having spent a whole day faffing about with serial output, OSCAL values, writing a bit of assembler code, I know, I said, look, the OSCAL value for this chip has got to be 5D. Hooray, I found it. And it was nice and stable at that point. And I go, what is the value they put in this chip then? And it's 5D. Yeah. I know, they've already calibrated the chip as well as it could be calibrated. There's no more calibration to be done on this chip. So I wasted a whole day working out what the OSCAL value was to try and get the serial output nice and stable, because that's where it matters. I mean, delays, you know, the millis delay bit, it doesn't matter if you're going to delay for, a few milliseconds less than what you should have done. But when that delay is used as part of the output, then of course it really does matter. So as you can see here, and what you've been watching as I've been wittering on, is that yes, the serial test string is coming out perfectly. This value you're seeing here, this number, that is in fact an unsigned long. And for some reason, it just doesn't like it. What I did to be able to print an unsigned long was copy the code from the Arduino core, stuffed it in here. I think I made a couple of changes and just go, and it worked. And then suddenly you get these big long numbers coming out of nowhere. I'm thinking, what's happening? Is something overflowing that I'm not aware of? Well, I'm not the expert on the ATTiny13, so I thought I'd have a check to see exactly what there was out there for this serial out there. Oh, look, now it's gone back to 12 and 13. I don't know what it's doing. I really don't know what it's doing here. I thought I'd check with the experts, and I found some interesting comments and a thread from just a couple of days ago. In fact, yesterday I think the thread was closed. So let's have a look what that's all about. Now, the first thing I loaded up was something called Microcore. We've already seen the mini core for the ATTiny85. This is the Microcore, and it only works on the really tiny ones. Like, in fact, this one here, as you can see there, it says it's for the ATTiny13, 30A and 13V, which is all to do with speeds, I think, that they can do, and what voltage they'll run at. So this is specifically for the ATTiny13, and the very fact it's there does indicate, yes, that this is a well thought of chip. It's being used a lot, because I don't think these guys, well, the Microcore is written by MCUDude, whose only name we know as of Hans, would be doing all this work if there weren't people out there to enjoy the fruits of his labour, if you like. And also, I found another guy who's got an absolutely great name. Let me just show you that. His name's absolutely spot on. It's this guy here. Here we are. So his name is Nerd Ralph. Ralph, what a great name, eh? Anyway, his real name is Ralph Doncaster, and he's been looking at the ATTiny13 amongst other things, and specifically looking at serial stuff. So what I want to show you, I mean, he's writing AVR stuff here, and it's sort of, I don't know if this one's specifically for the ATTiny13 or not, but there's one particular thing that I do want to show you between Nerd Ralph Doncaster, and MCUDude. They were talking about about a topic very dear to my heart. Right, now this is the thread of the conversation on GitHub between Ralph Doncaster and MCUDude, and because I was having so much problems with the serial output, and I've tried every which way to do it, and sort of got it working now-ish, I thought, what else are people doing? And I found this, and I go, oh yeah, how many years old is this? And as you can see, even now, look, this issue 8 days ago, and it was closed eventually. If I scroll all the way down to the bottom, it was it was closed 2 days ago. Well, today is the 1st of January, so that was in fact the 30th of December that was closed. And it's all about the fact that serial, in any shape, way or form, is just an absolute resource hog. So let me highlight the bit of code and zoom in a bit on this browser so we can see it. Right, so this is the sentence that caught my eye. I mean, for a start, it said put serial on a diet. Basically, it's too bloated. And what Nerd Ralph says was adding a single serial print to a sketch in Microcore, the one written by MCUDude, increases flash use by over 200 bytes and uses 12 bytes of RAM. Now let's put that into context. You've only got 1024 bytes, so 1K of flash memory to put your program in. You've only got 64 SRAM bytes. 64. Compare that to a 328p. We've got 32K flash and 2K SRAM, right? I mean, it's just a whole different world. When I was playing about with the ATTiny13, just to begin with, just putting stuff in there, I was getting so many compilation problems that it goes too big, too big, too big, and then, oh, really tight, it could have stability problems. And I think, but I've only done an LED blink sketch, and already it's complaining that I'm running out of memory. It really is brain dead. Oh, I said it again. Anyway, so having seen this sentence here, and realising it was Nerd Ralph who's done an awful lot of work on AVR type chips, and of course MCUDude as well, they were talking, I mean, I'll put a link to this so you can watch it yourself. So you can have a look at all this and just see what they were trying to get to. And, well, they didn't really succeed. What they've done at the end of the day, let me scroll down to the bottom of this entire thread just to give you that. So this is MCUDude now saying, I've concluded that it's just not worth spending more time on this. They were stumped. They couldn't get it to work properly. I'll copy some of the contents from, this is now Nerd Ralph's print.hcpp, changed into half duplex serial and call it a day. I'll close the issue when I'm finished. Again, thank you. So basically, MCUDude has apparently now updated Microcore, which I haven't taken the latest copy of, I must admit, just with the best that these two gurus of AVR code can do. So I'm thinking, no wonder I'm stuck and getting all these weird things happening when I try to do serial, because, you know, they're on a different plane to me. So what I'd say is at this time, yes, you do need Microcore, and potentially you have to use half duplex serial write only. So I think we'll just take MCUDude's Microcore as is, the new version, I hope, anyway, after the 30th of December. So I'm hoping to see an update in there from the 30th of December onward. And when it's there, I'm going to take a new version of it and just see how well that works compared to the bit I just showed you previously, which seems to work okay for strings. It's my number code that probably isn't working great. Hex bytes are okay, but, you know, how often do we print in hex bytes? I mean, you know, you'd be there forever trying to convert that. But I guess as a debugging tool to say, I'm starting, I've got this value at this point, just so you get some idea of what's happening in your code, or more importantly, where your code is probably going wrong because you've used the wrong variable or you forgot to initialize something. You know, it's so common to do that, but if you're working blind, forget it. So at least this gives us some way of moving forward. Now, okay, that's all well and good. Whether or not I continue with the ATTiny13, I don't know. I'll do a little bit more work on it and come back to you, because I know there's quite a groundswell movement there of people going, yeah, we should be using this chip more. They're so cheap, we can put them anywhere. Well, okay. Well, I've got a challenge that I'm sort of setting myself, but really it's also because you guys have said use the ATTiny13 when you need to. I have a fridge door alarm, which started off, I don't know how many years ago, 10 years ago, as a 555 timer. All right. So when you open the door, it starts the timer running, and if your door isn't shut within a certain amount of time, it starts bleeping. That was the simplest 555 timer circuit I could ever come up with. Then I rewrote it, or wrote it properly in code with a PIC chip, and it became a little bit more sophisticated. So you'd open the door, it'd make a noise, it would time itself as it as the door was open and made various bleeps, and eventually continued bleeping. Great. Then I rewrote it again for an Arduino Nano. Yeah, I know. I know, it's good practice though. And what it does now is pretty much the same. You open the door, it makes a little noise that Benny and Dougal, the dog, have come to recognise and go, oh, fridge door's open, what's he going to get? And they all come running out. And after 30 seconds it beeps once, after another 15 seconds it beeps twice, and eventually after about 2-3 minutes the big bleeper that I've put in there goes off so you can hear it throughout the house, because we've lost all the contents of our fridge a couple of times years ago, and we thought this is no good. It's because, would you believe it, the irony of it is the door closes and there's a little switch at the top to turn the internal light off, and the door closes, hits this switch, and because the switch, although not exactly fully sprung loaded, it is the certain resistance, it touches it and stops. So it touches it just enough to turn the light off, which is why I can't put something inside the fridge because I think the door's shut. It just touches that little dongle, if you like, turns the light off, but doesn't shut the door. And we've come down in the morning and all our stuff's been spoiled. So it now uses a magnet on the outside. So I'm thinking, okay, using a Nano for that is well out of order. I mean, it's just ridiculously stupid, but it was a good thing to build, you know, 10 years ago or whatever. So what I think I'm going to do, I'm going to try and build it using a ATTiny13A. And if I succeed, then I'll eat my words that this is brain dead, because it obviously can do some stuff, but it is very limited. Of course, putting in big serial statements into your code is silly, because that's going to use up all the RAM straight away, so you have to be very careful about that. But I'm going to see if I can build it using this, and I'll get back to you in a future video. And the way I'm going to debug it is on a circuit board. And if you remember last time I said, how do you debug these things or program these things, loading up sketches or whatever, when you haven't got one of these little things to hand? You know, like this chip is now on a circuit board, a breadboard or a circuit board, so it's on something like this, and then you have to have dew point wires and all that. Well, there's something in the offing. I was hoping to get something ready for this video, but unfortunately New Year got in the way. So what I've got is stuck in a Chinese PCB factory at the moment, but that'll be here probably for next week or the week after, and we'll talk about that in a little bit more detail. It doesn't necessarily just mean we're going to talk about the ATTiny13A. It also will do any 8-pin AVR chip. So that's something that I will use as soon as it turns up to develop that fridge door alarm. We'll just see how well that works, eh? Right. I think I'm gonna sort of stop there. There's loads of resources, by the way, for all these little chips from ATMEL or Microchip themselves. They go, right, if you're going to use these sort of chips with limited memory, there's some various coding techniques you really ought to think about for, you know, getting your code small and compiled. And incidentally, I must say, the Microcore really does squish that code down. But the Microcore is definitely what you need as the fundamental core, the core code for this chip. Don't use the standard ATMEL one, it's just too bloated. You'll never get anything in there. As I say, I was doing the LED flash blink sketch, and it was complaining all over the place, and I thought, well, this is ridiculous. Right, just back to the ATTiny13A code, because it's something I forgot to mention. Pre all that to and fro between Nerd Ralph and MCUDude, I could not get that ATTiny13 to talk down the serial port at all, no matter what I did. So the underlying Microcore serial just didn't work for me at all. What I've used is something called basic serial, which is one way only, just to send stuff out, which is what I want. So this is my little tiny sketch, as you can see here. Let me see if I can make that a little bit bigger, shall we? Right, so this is the code. Basically, it's just a send stuff out the serial port using basic serial. So here I'm using basic serial at the top there, as you can see. Now I've included util delay so that I don't use the actual Arduino delay function. I actually call underscore delay underscore milliseconds. It just saves a few bytes. And believe me, we need every single byte we can get. There's my little OSCCAL calculation, look. Hex 5D, which I spent the whole day doing and didn't need to do at all. Lovely. Yeah, so the bit that's going wrong on here, serial out, that works okay in this basic serial, but print number doesn't, and that's my code, so it's my mistake. There's the library. So if we look at basic serial, Now mine's in a CPP file, so let's have a look at that. There's my print number, and it's just stolen from the Arduino core. And what I don't understand is it works, as you saw, most of the time, but not all the time. So there must be something underflowing, overflowing, just getting corrupted. I don't know. I've a bit like Hans MCUDude and Nerd Ralph. I've had enough of this as well. I'm just going to wait until Microcore puts the hardware serial or whatever he was going to do, update something, and wait until that works really before I do any more, so I can get rid of them. We've got to have somewhere though printing numbers, but even if we don't and we're stuck on hex, at least we can put out little strings, as I said. Yeah, so easy enough. I'll put all the links to all that I've mentioned, you know, basic serial and Nerd Ralph's code and MCUDude's code. I'll put all those underneath, plus all those ATMEL cheat sheets, because if you're going to get into the ATTiny13, it's a really good way to learn. Believe me, if you end up creating sketches for the ATTiny13, when you go to the 85, you'll think, I've got so much room, because you've got 2K of space and more SRAM. I can't remember how much the ATTiny85 has actually, but of course then when you go to the 328p, well, you're in silicon heaven, aren't you? Now if I compile this, I think we'll just see how much space this takes, shall we? So let me just get the windows in order, and we'll do that. Right, so it says 0 warnings, yeah, because I've compiled it before. So this is taking 446 bytes and 14 bytes of SRAM. Just this. So I've used half the space just to do that little test out. Half the space available. Yeah, this is what I mean. You have to be a little bit creative, I think. Now, obviously, just so that you're aware that I'm aware, putting things like this in, that's taking up 1 byte of SRAM for every single character, and that's probably where the 14 are being used actually, plus the counter, that's another 4 because it's an unsigned long, and that's all the SRAM probably being used. So liberally sprinkling your code with serial out statements, or print.serial or serial.write print line, or whatever it is on the Microcore, is probably not a good idea. You just want to focus on the bit that you think's going wrong and work from there. Okay, enough of this. And finally, just before I leave you, because I'm spending an awful lot of time over Christmas creating PCBs, EasyEDA has a new update. As you can see, this is version 6.322, and there's quite a bit in it, you know, new features and bug fixes and things. So it's worth having a read of that if you're into EasyEDA, and why shouldn't you be? It's a great little tool. Okay, that's it for the first video of the new year. My workbench is in a bit of disarray because all the stuff I've been doing, but I'm going to continue with the ATTiny13. Oh, okay, one last thing, one little tip. If you notice, I've written on that chip there, 13A, because one, with my eyes, I'd never be able to read the tiny little writing on there, but even then it's quite a struggle. So what I've bought is 6 of these pens, paint markers they're called. It's a bit like writing with typewriter correction fluid, except you've got a tiny little nib to do it with, but the actual stuff inside, it's supposed to be some sort of paint stuff, and it probably is better than correction fluid, but you have to shake it like mad until the little ball bearing, can you hear it? Probably. Anyway, you shake it like mad, you push it down the plunger way. Let me do it on here. So on here you have, you know, you push it like that so the nib goes in, and eventually ink flows, but that's not good enough. You still have to do it, and eventually you can get some white stuff. And I've done this on a couple of relays so I don't get them muddled up, but more importantly for me, I'll now do it on the chip. So the 13A's got it, and I've got a 85 somewhere on my workbench here that's also got it on there, if I can find it. Anyway, I'll put a little picture up there just to show you, but it's one of those, you know, the best of a bad job really. I mean, this paint stuff, I wouldn't call it brilliant, but it is the best of what's out there, I think, to be quite honest. In 0.7mm, I could do with something like a 0.4mm, to be quite honest. But I got these, where did I get these from? It wasn't from China. I think it might have been from Amazon. I'll put a link if I can find it. Okay, but you get about 6, and it's about, I can't remember how much it is now, £6 or something like that. But for writing on things like this, it's a godsend for me at the moment. And of course, for relays, I've got some 12-volt relays and some mains powered relays, and if I got those mixed up, that would be quite an interesting little explosion, wouldn't it? So I've written on those as well. Ah, there we are. Look, there's the little pictures of what I've done. There we are, you see, all organised. Right, that's it then. Enough for today. I love your comments on the ATTiny13 Brain Dead chip. Oh, I'll say it again. I'd love to know what you're using the 13A for, because it's so limited in memory. I'd love to read about it in your comments. Don't forget to tell YouTube if you like this video so that they send it out to more people. January is always a very slow time in YouTube world because people are going back to work. They're not thinking about YouTube and videos or not. So yeah, tell them that it's the best video you've ever seen by giving it a thumbs up, and then maybe they'll send it out to more people. Great. Okay, that's it. Happy New Year again. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.